So Linaro is a global open source software engineering company. We're working on kernel code, implementing some of what Greg's been talking about. And we're also working on Android, which is going to be the topic of what I'm going to talk about now. There are 4 key objectives, a lot of other objectives, but there are 4 key ones we're focusing on. Do not fork Android, bad thing to do. Use common code for different SoCs. Sounds easy, very difficult. Implement module hot swap, and define standards to allow you to support and develop custom modules that we can't even think about today. So for forking Android, we need to specify a single generalized HAL for each device type. Today, every vendor goes and makes their own custom changes to HALs. That's not going to work. We also need to ensure full Android API compliance so that applications that exist today run on these phones. For different SoCs, we have to enable SoC vendors to rework their vendor-specific framework customizations, and we need to give them information on how to do so and provide some reference examples. For module hot swap, we need to implement runtime detection of hardware, and we need to dynamically enable and disable features. So if you take a camera out, your camera application has got to know about it and give you some useful feedback. And finally, we have to implement a set of standard interfaces to develop and integrate non-class conforming modules. So some of the challenges. The same software must work for each device class. We must be able to add and remove peripherals at runtime and have the applications change their behavior accordingly. We have to select the best device if you've put 2 of the same device into an Ara phone. And we have to be able to update the security policies at runtime. Why is this difficult? Because today, in Android, HALs, how you download firmware into modules, whether it's a Wi-Fi module or chip or in your phone or whatever, they're different for every vendor. Today, capabilities are statically defined at build time in Android in read-only files. We have to change that. Today, the software framework assumes only 1 peripheral of each type. Well, in Ara, you can have multiple peripherals, and you need to be able to choose which one you want to use for a particular application. And today, security policies are defined statically at build time, so we have to change that as well. We have to make the ability to change those policies in runtime when a new module comes in. So how are we going to do this? Well, the first is we're going to require module firmware to do initialization and vendor customization. Don't worry, if you don't want to do anything strange, you don't have to do any of this. But we have to keep the HAL and the driver generic by moving software that's not common to everybody onto the firmware on the module. So this happens today for things like Bluetooth devices, where a firmware blob is downloaded onto the Bluetooth module. We're going to provide standardized ways of doing this. We also are going to encourage using smart hardware. So limit the customization that's required in software and rely instead on generic post-processing libraries. So for an example, on a camera, use a smart sensor instead of a raw sensor. So put the stabilization hardware into the camera module and not onto the AP. Device classes and sysfs, we're introducing ioctls and sysfs entries into the kernel to generalize the HAL. And we're also providing a new endo service for the Ara Manager application that I'll describe in a minute. So some of the changes that are in progress. Starting at the bottom, where Greg has described Graybus and the kernel, we're porting libudev, which will help us to detect module status insert, the removal of modules, powering them up and down, and so on. In the HAL, we're splitting the HAL so that we have split between data read-write operations and post-processing libraries, so that we can provide a set of generic post-processing libraries for different HALs. We're also requiring only standard calls. So there will be ioctls associated with each device class that you can use. And we'll also support dynamically loading firmware based on the vendor ID and product ID, and that will be done in conjunction with the Google Play Store. So you will be able to have firmware for your modules that's downloaded at runtime when the module's inserted automatically from the Play Store. And don't have static entries. We need to get the configuration from the module and the driver and the app. In the media server, we're going to remove all those wonderful vendor-specific customizations and require the use of standard libraries like V4L, Video for Linux, and then any further optimization will have to be done on the modules. And the system server, we're managing the Ara modules and the Play Store support with new services specifically to support Ara, and we support hot swap and reconfiguration in the system services. On the binder, we have to update the binder to close applications automatically when the associated hardware is removed so that they don't crash. And finally, at the applications layer, we have to make sure that we're CTS compliant so that Play Store applications can be supported. And we need to provide a new Ara Manager app to handle modules easily and efficiently and let users have a good experience using their phone. But what about non-class conforming modules? What about those special modules you want to create to do some crazy things that we haven't even thought about? They're not going to conform necessarily to a device class. They're going to have some functionality that we can't imagine today. So, as Greg says, in the kernel, we're plumbing in functionality to enable you to get access to the hardware buses. From a module developer's point of view, you will just use an Ara peripheral API library that we will provide you to implement your Android app. You do not need to know anything about the complexities underneath. And that will enable you to directly access the peripheral devices. So, for example, I2C, or GPIO, or SPI, and so on. And then underneath that, there's a framework that is implemented by us for each peripheral. That will be available in source code as open source in the repository that I'm going to talk about later. And finally, we're implementing device classes for each peripheral interface to enable all this to happen. Ara Manager application. So this application is always running. It can be launched like any other Android app. And the objective is to enable the user to have a good experience using the phone. So it will provide functionality like touch, drag, if you want to lock or unlock a module, power enabling and disabling, gauges for all of the batteries. Right? Using Android normally, you'll just, as normal, have your single battery indicator at the top, which will be an amalgamation of all the battery information. But if you want to go and look at what storage is available on each battery, you'll be able to do that. You'll be able to get module statistics, vendor info, and so on. You'll be able to organize the cloud retrieval through this app of updates to software on your modules. And we'll also provide user assistance to highlight issues, like it might be better if you put the camera in this module, because then, as Dexter was saying earlier, you might get a better user experience. So there's a new Endo service being developed for Android to provide the functionality to support this application. So what's going to be available in the MDK 0.2? Well, I've talked an awful lot about some things that the software developers amongst you will know are going to take some time, and I'm afraid they're not finished yet. The design changes are in progress. We've identified and discussed what we're going to do and how we're going to accomplish all this with the Android team at Google, and we're busy implementing now. They have not historically been available anywhere in public. However, as part of the MDK 2, the Android Common Code Base Git repository will be made completely open with effect from today. Code exists and has been posted online to enable you to start to look at this software and to help us as we develop. Developers will be able to work on the bleeding edge for module development, and will provide instructions and documentation on how to download the sources, how to build and boot for the developer hardware, which is going to be described in the next talks, and how to use reference modules and the Marvell and NVIDIA AP platforms. That will include an implementation of Android on the Jetson NVIDIA platform, which is used as a development platform for the developer hardware that's going to be shortly described. Soon we'll be also focusing on some additional areas like HAL generalization and hot swapping for modules that are not reference modules. We'll be doing power management work. We'll be handling validation and compliance software to test modules, and we'll also be implementing security policies for each device. So thank you very much. If you're interested, and I'm sure some of you are, you can get code today by going to github.com/Project Ara. The initial implementation is an Android implementation for Jetson, which is used as the starting point for the developers to be able to use the developer platforms that are going to be described in the next talks. Thank you very much.